Okay, hello everyone. My name is Ben Martin. I'm Secretary General of the Ocean Thermal Energy Association. The Ocean Thermal Energy Association is a volunteer organization. We collect, coordinate, and disseminate information for stakeholders on all ocean thermal energy technologies, including desalination, cooling, and of course, OTEC. So we're very pleased to welcome you to the first National Perspective analysis of ocean thermal gradient energy in Costa Rica. I'll turn it over to our presenters. They'll be able to introduce themselves, give a presentation, and after the presentation, we'll have time for questions. Until then, the video and audio of all attendees are muted. So without further ado, I'll turn it over to you. Thank you.
Yes, thank you very much, Benjamin. Yes, my name is Rodrigo Rojas. I'm from Costa Rica. Now I'm working as a lecturer in National University, Universidad Nacional de Costa Rica. And I belong to Red Mare. It truly is a Costa Rican cluster of marine energy research network. For me, it's a pleasure to share this stream, this moment, to get in advance the results of the long-term investigation dealing with prospective foresight analysis of the OTEC potentials and opportunities to use here in Costa Rica. But before to give some ideas about that, I would like to introduce my colleague Pablo. Pablo, please.
Good morning, everyone. I'm Pablo Mora Céspedes. I'm also from Costa Rica, and a student. I'm still student of the University of Costa Rica, but also I did my presentation, my thesis degree related with OTEC, as Rodrigo said. I'm so happy to be here and to share with you the results of my thesis degree, and also with the new things that we could get with this presentation.
Yes, in special for OTEA members, I would like to give you some insights about or milestones about Costa Rica. It's a small emergent economy located in the middle of the Central American tropical belt. Our country is one of the greenest nations with close to 27% of the continental and marine territories truly protected under different kind of conservation areas. And we are proud to say that our country covers only close to 0.03% of the surface of the globe, enclosed shelters close to 5% of the all biodiversity exciting in the entire world. As you see, we are 10 times. This is very interesting for not only OTEC research, but also for wave, tides, current, offshore wind potentials. Our country is 10 times more ocean territories than onshore land. This is very important for us. Here you can see in very brief way what is the evolution of our renewable energy matrix, starting with hydro to in the 1840s to now in the last decade. We are moving with different kind of energy sources in our mix: hydro, thermic, geothermal, biomass, wind, solar PV, storage, battery storage, and now our next frontier. This is very important for us. Our next frontier is moving to the blue energy challenges. Between them, of course, OTEC. Here in this slide, you can see what is the history of the electricity generation in the last 6 years ago, starting in 2019 with close to 97% of our electricity generation is based on renewable energy sources. Till now, we have in the last years, we are very close to 100%. Here you can see what is our real challenge. If you can see in your left side of your screen, what is the current continental installed capacity, energy coming from hydroelectricity, geothermal, solar PV, aeolic onshore, biomass. But in your right side, you see OTEC is waiting to be developed. Up to now, we have 0 kilowatts coming from ocean. This is the real challenge. But what is the good news? The good news is Costa Rica has marine energy potential, theoretical potential. In our last publications, where Pablo is also one of the contributors, we demonstrate what Costa Rica has in different kind of marine energy. Between them, OTEC, current, wave, tide, and offshore wind, that we have a very good potentials. Speaking about our partners for OTEC research, we have academia. You can see different public and private universities, but also public and private corporations or institutions who are helping us to moving forward into OTEC research. Pablo, this is my message and your screen, and now the screen is yours, please.
Okay, thank you so much. Let me share with you the presentation. Can you see the screen?
Sí, pero tirarlo
Yes.
en pantalla total.
Okay.
Ok, perfecto.
Can you see the screen? Yeah. Okay, good.
No, Pablo. Ahí sí.
Yes, go
Ahí
ahead.
está, Pablo.
Okay, thank you so much. Good morning, everyone, again. I want to start with the introduction of myself. As I said in the last presentation, Rodrigo's presentation, I'm a student of Sustainable Development Engineering at University of Costa Rica, and also I'm a student in Turrialba's campus. Today, I'm so happy and so proud to share with you the result of my thesis degree, prospective analysis of the potential for harnessing energy through ocean thermal gradients in Costa Rica, the first investigation related with OTEC in our country. And I would also like to thank the support of my advisory committee, Dr. Rodrigo Rojas Morales, that is here. Thank you so much for all your support and your help. And Dr. Alberto Diaz-Tey and Dr. Ronnie Mora Escalante. And also I want to thank the different institutions that made this webinar possible. Red Mare Costa Rica, University of Costa Rica, National University of Costa Rica, and obviously Ocean Thermal Energy Association for the opportunity to be here. Today, I want to emphasize in this part that Rodrigo said a little bit about Costa Rica. We have to keep in mind that Costa Rica is that small country that you could see in the map. And something important that Rodrigo said is that we we have a lot of biodiversity. We have around the 5% of the biodiversity in the 0.03% of its territorial area. That's something important, really important for us, because that means that Costa Rica is a country rich in biodiversity, rich in protected areas, and also with access to Pacific Ocean, and also to the Caribbean Sea. That is so important for us. As we can see in the image, we have a huge study area. We have the Pacific Ocean in this part, and also the Caribbean Sea here. What happened? We have a lot of area for energy resources, thinking about OTEC, 10 times bigger than land. And obviously, something really important is that Costa Rica currently generates 0 kilowatts from ocean energy resources. That means that we have a good opportunity. We have a good opportunity to develop new technologies and to do new research related with marine energies in our country. Why do we have to start thinking about OTEC as a real alternative or biodiversification of the renewable matrix in Costa Rica? We have a lot of reasons, but today we are going to talk about 6 of them. The first one is population growth. Costa Rica is a small country with around 5 million of people, but that could change in the next years, changing 5 million of people for 6 million of people. The second reason is related with the first one, because usually when you have population growth, you also have an industrial growth. So basically you need to look for a new solution, new energy resources to cover the demand of energy produced by those activities. The third one, Rodrigo said in his presentation, and is something really, really important for us, because Costa Rica has a high dependency on hydropower resources. As you could see, we have more than 65% of hydropower resources. And what happened in phenomena like El Nino, or what happened in dry season, and what could happen in the next years with climate change. We need to look for new solutions, and OTEC is a real alternative for us. We have an abundant potential because Costa Rica is located in a tropical area. Costa Rica is in a tropical area that is ideal for OTEC, because there we can find a warm ocean surface temperature, a high temperature there, and also we could have a cool deep ocean water constant throughout the years. We have another reason, important reason, that is that OTEC is an underexplored technology in Costa Rica. As I said, this is the first investigation related with OTEC, so this is so important for us. And last but not least, we have energy stability. As you know, OTEC could produce energy 24 hours, 7 days per week. That is ideal for our country and our context. Now, talking about the research objectives, we have in the investigation had one general objective: analyze the potential of ocean thermal energy conversion, OTEC, through a sustainability framework to access its implementation in Costa Rica. Composed of 3 specific objectives: spatial variability, determine viable zones through GIS and multi-criteria sustainable matrix; energy potential, evaluate the theoretical energy potential using Rankine cycle simulations; and institutional framework, identify gaps and competence through hierarchical review and expert interviews. And now, the methodology. We divide the methodology in 3 principal phases. The phase 1, related with site selection. We use 3 minimum criteria for site selection. Bathymetry, as you can see here, more or equal than 800 meters, surface temperature more than 22 degrees, and distance to the coast less than 15 kilometers. Also, we create our own multi-criteria matrix conformed of thermal gradients, weather conditions, contemplating hurricanes, tropical storm, extreme waves, geographic context related more with the distance to the coast, human activities, fishing, distance to fishing area, tourism areas, and also indigenous territories. Environmental conservation related with the distance to marine protected areas, and ecological conductivity, the distance to mangroves, corals, and seagrasses. In the phase 2, we did a thermodynamic simulation. For that, we used 3 design assumptions. We use Lockheed Martin mission and system sensors. We use Shell 2024 and McDonald 2022. And we decided to use as a working fluid ammonium, the different pumping efficiency and turbine efficiency that we use. And also we could get the mass flow of those design assumptions. After that, we could develop our simulator using an ideal Rankine cycle based on Nihau's normally scale, considering seasonality of Costa Rica, dry season, rainy season, and transitional months. Here it's important to emphasize that for the phase 2, the thermodynamic simulation, we use the information of the 2 sites with the highest potential for OTEC according to the multi-criteria tool in the phase 1. For the phase 2, we did a hierarchical review, analyzed the political constitution to operational decrees and international treaties. And we compare that information in the first step with expert interviews. We comparison the information, the environmental law, the marine governments, and that with the objective to identify gaps and opportunities in the legal framework. And the last step of this phase was the stakeholder mapping. We did a classification of institutional actors according to power and interest to determine their roles in a future OTEC project in our country. And now talking a little bit about the results. In the phase 2, we identified 12 potential sites around the country, the maritime area, 8 of them in the Pacific Ocean, as we could see here in the image, and 4 of them in the Caribbean Sea. After the multi-criteria analysis, we got the 2 sites with the greatest potential for OTEC according to the multi-criteria tool. As we could see here, the site 2, Burica Zone, and in this case, the site 3, Corcovado Zone. But the most important thing here to emphasize is that, as we could see in the left side, we have serial complications in the case of the site 2 with human activities. We could see here that we have a 33% of performance in that specific factor, and in the site 3 we have the low performance in environmental conservation. This is something really important to emphasize, because the main results say that site 2 is located near indigenous territory Nahue. As we could see here in the image, we identify a potential site so close to indigenous territory that we have here in the red color. And what happened with the site 3? The site 3 is located close to Corcovado National Park. Here is important to say that if we could see here in the image, in the map, the potential site is not in the protect area, but is close to. So that means that it's important to keep in mind that we are close to Corcovado National Park, and we also are close to an important indigenous territory. And what happened there? We have an indigenous community, we have an area rich in biodiversity, we have a rich area in the terms of tourism for our country, we have in a rich area with cultural terms, and we have the Corcovado National Park. That is basically the most important national park in our country, with more than the 12% of the biodiversity around the world in that specific national park. And now we have the question, what is the energy potential for these points? The results of the phase 2, the energy potential, we have the site 3 Burica Sun in dry season that goes December to March in the order of 139 megawatts according to the simulations. In the rainy season, May to October, in the order of 133 megawatts. Transitional months, April to November, 131 megawatts, and average 132 megawatts. As we could see in the image in the right side, we have the behavior of that results. We have dry season here, rainy season, transitional months, and the average. Something really important here is also the gradient that we could get in those different seasonalities. We have the dry season with the highest gradient, followed by rainy season and transitional months. The site 3, Corcovado Sun, we have in dry season 114 megawatts, in rainy season 133 megawatts, and transitional months 132 megawatts, and average 114 megawatts. We have the same behavior. We have the dry season here with the highest gradient, followed by rainy season and transitional months. Here is the results that we got about with our simulations. With our simulation, we have a Rankine ideal cycle, evaporator, turbine, condenser, ammonia pump, and their different parameters. We have temperature, we have pressures, we have enthalpies, entropies. As we could see here, we have the temperature in that specific site. Temperature, we have the warm ocean surface temperature in here, and after the process in the evaporator, in this case, the pump consumption for the evaporators on the pumps for surface water. And here we could see the cold deep ocean temperature in and the cold temperature out after the heat exchange process, and also the pump consumptions. And something really important is that as we could see here, is the net power according to the average for the site 2. In the site 3, Corcovado Sun, we have the same image with different results. As we could see here, we have the different parameters according to the site 3, Corcovado site, and we have temperature in, temperature out, and its net power produced by all the Rankine cycle. And now we have the different parameters to compare the site 2 and the site 3. We have pumping power in the order of 30 megawatts. Something really important here is that we used and we create an ideal Rankine cycle simulator, and also this is the first investigation, the first simulation Rankine cycle related with OTEA. So we try to compare the result with international literature, and the different results that we had. In this case, we could see the net power for site 2 and for site 3, Carnot efficiency in the order of 7.65% and 7.76%, and cycle efficiency in the order of 3%. And we have the main results for phase 2. And the first one is that decrease in thermal gradients requires increasing the pumping rate to compensate for the smaller temperature difference. The actual cycle efficiency, 3.21% and 3.34%, are consistent with values reported in international literature. That is so good for us, because that means that we could design a real ranking ideal simulator related with OTEC. And we have the seasonal variations in the system net power's output depend primarily on ocean surface temperature. And there's phase 3. We have some important results. We identified 37 legal resources applicable to the use of marine energy in Costa Rica. The most important: political constitution, biodiversity law, wildlife conservation law, and organic law of the environment. And also we identify the main institutional actors identified in environmental and social acceptance permits. We identify the ICE, National Institutional of Electricity, INCOPESCA related with the tourism and also with the fishing part, CETENA related more with the permits in the environmental part, MINA related with the nature and everything related with these projects in the terms of nature, and local governments. In the marine use permits for energy, we identify ICE, Dirección de Aguas, CETENA, MINAE. And operating permits, we have ICE again, INCOPESCA, CETENA, MINAE, local governments, and MOB related with the construction of ports in our country. As we could see here, we have something really important, that we have the same institutional actors for environmental and social acceptance, marine permits, and operating permits. And now we have the question: what opportunities and challenges does the legal framework present for OTEC? We have a challenge. We identify a challenge because we don't have regulatory framework for ocean energy in our country. And also we have a lack of defined regulatory body. We have a limitation because we have a lack of information about the technology and its potential impacts on human activities, and also with the potential impacts on ecosystems. We identify, as I said in the last slide, we identify principal actors with the greatest power and interest: ICE, CETENA, and MINAE. But also we have a recommendation, that is review OTEC legislation in countries that use OTEC plans and try to adapt or recreate the legal framework to our country. And also we identify that experts point out that public works concession by ICE is the only viable mechanism today for an OTEC project. And now, here in this part is something really interesting is that we didn't contemplate this part in our thesis, but we start thinking about, okay, we have information about theoretical sides. We know the side, right? We know the legal framework, and we also now we know about the environmental part and also with the social part. But what happened with the vulnerable species and ecosystem of that specific sites? We did 5 interviews to an experts, and we identified that we have serial complication in the terms of ecosystem and vulnerable species. We have the problem with migratory species. South Pacific part of Costa Rica is a so important part in the terms of biodiversity, because there we could see whales and many marine species depend on that specific part to have the migration routes. But also we could have some troubles with coral reefs. You know that the water, deep water intake and cold water discharge much affect the coral, bentonic coral ecosystems that we could have there. And also we have the pelagic fisheries. Sharks, tunas, locust fisheries are really important in that specific side of our country. And the key conclusions, we have that Costa Rica has a high OTEC potential on both coasts. However, the multi-territorial analysis identified the South Pacific as the most viable zone because in that specific site we have the subduction process. So that means that we could find ideal conditions for OTEC really close to the coast. And we also have the conclusion that implementing OTIC requires a strict marine spatial planning to mitigate conflicts with the different activities that we identify. Indigenous lands, we have indigenous land in one side, and also we have a national park in the other side, potential side. We have the thermodynamic simulator confirms valid net outputs capacities, yielding cycle efficiencies in the order of 3%, consistent with international literature. Regulatory, in the terms of regulatory part, we identified that Costa Rica legal framework prioritizes protection projects, and for that reason, projects such as OTEC demand rigorous environmental assessments and specialized legislation to do it real. We have that project viability absolutely depends on multi-sectorial participation led by the institutions with the highest power and interest. In this case, ICE, MINAE, and CETENA. And now we have the question, what's the next step? Okay, I think that for the context, and this is the first investigation related with OTEC, we have to understand OTEC first. This is the first step. We need to continue this investigation way to understand OTEC, to do some simulators on other research related with the performance of OTEC, the real performance of OTEC in that specific site with the real conditions. We need to mitigate risk, and we need some collaboration through joint research and a strategic alliance. Because with that strategic alliance, we could continue this investigation, and also, why not try to investigate not just in Costa Rica, and why not in Central America, in all the Americas, continue with this investigation related with OTEC. And in the near future, why not envision the development of OTEC prototypes in Costa Rica and across the Americas? Thank you so much for your time.
Congratulations, and thank you for the presentation. So going forward, we'd like to open up for questions.
Ben, there is some kind of echo.
Yes, I think maybe one of you might have a speaker.
All right.
Okay, so we'd like to open it up to the audience. If you have questions, I think you can use the raise your hand option, and then I can give you access to mic and video, or you can put them into the chat as well. So let me start allowing one. Okay, Dan, go ahead.
Hello, good morning, guys. I just want to say, congratulations, Pablo, for the amazing study, and thank you for picking OTEC as a field of research. Also, thank you, Dr. Rodrigo, for your leadership in this sense. I know that is vital to the development of this framework within Costa Rica. I think two things stood out to me. One point that I found somewhat alarming, and I'd like to understand how you factored in the weighting of scoring, is that you had I think it was site number 2, involved a location that was 100% conservation zone. Is there any precedent for Costa Rica deploying new technologies in conservation zones? And wouldn't this be such a strong argument against the location that there must have been more viable locations that maybe took a hit on say, thermal transfer, but you didn't have to then contend with a conservation zone. And then my second question is there any planned analysis of the techno-economics? So I felt that was the only area. Yes, please go ahead.
Excuse me, if you want, we can try to answer the first and then move into the second, please. Pablo, go ahead.
Okay, let me try to. I think that I understand your question related with the that the site 2 is located close to a national park and conservation area. The multi-criteria tool, and in that multi-criteria tool, we contemplate the distance to protect areas. But the thing here is, in Costa Rica, we don't have anything related with legal framework that could say, no, you can build an OTEC plant there because you are close to a conservation area. But the reason is the specific reason is that we don't have a legislation about anything related with marine area. And obviously, in the multi-criteria matrix, we contemplate distance to those specific areas, and we also prioritize the different areas. But the performance of that specific site in the other factors are so high. So that means that we have an opportunity there, but that means that we have to keep in mind that we are also close an indigenous part in the indigenous territory, and also close to protect area, Corcovado National Park, and also an rich area in the terms of biodiversity. So we have the opportunity there. We don't have anything that could that say that we cannot build an OTEC plant there, but we have to keep that in mind if we want to continue with a potential OTEC plant.
Dan, I would like to add something about your questions. I believe that we are in a good position to move forward into OTEC in Costa Rica. However, I will say our national legal coastal and marine protection system is quite difficult for us because it's very strong. We need to put together all stakeholders to talk about the new possibility to use not only OTEC, Dan, look, not only OTEC, is the same bottleneck for waves, tides, currents, offshore challenges. It's the same because we have very good potential as I showed in my short presentation. However, we have legal constraint and legal indefinitions. Look, Dan, we have legal indefinition till now. Pablo, do you like to make some extra comments?
No. I think that that's the most important. In the legal part of this research, we identified that we don't have anything related with marine, specific laws related with marine area, and we don't have a regulatory body determined in Costa Rica. That's so difficult for us, but we have also an opportunity.
Dan, our next step is try to solve the legal gaps in short. Please, your second question, please.
Yes, no, thank you very much for your answers. And you're very much aligned with what I'm recognizing here is that a lack of legal framework could find the project almost in purgatory forever, because it is down to lawyers and politicians who maybe change posts over time, making decisions, and they are worried about making the wrong decision. The next point I had was on techno-economics, because Costa Rica has always stood out as, it maybe rightly or wrongly, is held up as being one of the success stories of net zero in relation to the hydropower capacity. I very much understand that is both a blessing and a curse in some respects, because when you don't get the sufficient rainy seasons, then the power that is relied upon does not come. And I understand why OTEC is a very good alternative in this respect. However, hydro is one of the cheapest forms of renewable energy. in the world, and OTEC is one of the most expensive forms of renewable energy. So how will you form the next steps of your studies to address this? That's my last question. Thank you.
Paulo, first.
Yeah, actually, we are working on another paper related with the economic part that I think that is gonna be so important for us, because this research is more a general research, the identify potential sites and everything in general terms for OTEC, but we are working on a new paper related with the economic part, and I think that those results are going to be so important for us, and also to compare with the renewable matrix energy of Costa Rica, and we will see what happens. I think that OTEC is not a real is not a real opportunity for nowadays, but probably in the future we could change that, and yeah, we are working on it.
Then, in complementation to the answer of Pablo, yeah, you are right. You are right. But now our vision is not put together a competitive race between hydropower and OTEC. It is not, it's unsense to try to compare similar cost. We understand perfect what is the next for Costa Rica. The current goal is trying to advance into the new portfolio of opportunities for the next decade, for the next 20-25 years. I will say that because I work for Costa Rican Institute of Electricity. Is the company who are in charge to prepare the research on the new ways to get renewable energy in Costa Rica. And our objective for now is try to answer what is the opportunity of the blue energy for Costa Rica for the in foresight perspective, in prospective vision. For now, we are not thinking to compare levelized cost of energy between hydro and OTEC, or OTEC and geothermal, or OTEC and solar PV, or OTEC and biomass. We are not doing this kind of comparison because we are clear that those source of energy are cheaper than OTEC now. What will be the future? We don't know. We are preparing conditions to moving forward. Then that is our answer.
Yeah, and I think to complement the answer, and I think that this is the first investigation, so we need more information, and we could start and combine OTEC with another ocean energy, so maybe another characteristic of the OTEC cycle. And I think that first we need to understand OTEC, and after all, we could start thinking about to compare if it's possible or not in the future.
Ben, we have two
Okay,
questions. Mark
yes, we have
and Troy, please. Mark.
So I think Mark may have, I can give you the mic and camera.
Pablo, en
So
el
go
chat
ahead,
hay
Mark.
una pregunta, si quieres verla. Pablo.
So I've given you access to your mic and camera, but just in the meantime, I'll read from the chat. Can you tell us something about the 6 other potential sites? The 2 sites chosen seem to be vulnerable. And how do the sites relate to existing infrastructure for distribution? I think maybe what this is aiming at is kind of what's the proximity to potential off-takers of the energy or use of that OTEC.
Indeed, Pablo.
Yeah. As I said in my presentation, Costa Rica has a high potential for OTEC on both coasts. That means that we have a good potential for OTEC in the 2 and the 12 sites that we identify. The thing here is that we create that multi-territorial tool, but we have potential in the Caribbean Sea and also in the Pacific side. But you have to keep in mind that we have a lot of protecting areas. We have a lot of, for example, indigenous territory. We are a country that we have a lot of tourism. So we contemplate those characteristics, and according to that, we select the 2 sites with the highest potential. But that doesn't mean that the other sites are not potential for OTEC. So that's gonna be depend on the analysis that we did in this case. But for example, in the terms of distance to the coast, in the Caribbean side, for example, we have we have distance close to 22 kilometers to the coast, and the Pacific side and the 2 sides with the highest potential, we have distance like 8 kilometers to the 1,000 meters. So that's the most important reasons for the site selection in this case.
Okay, thank you for your answer. And I'll give access to Troy Miller next. Hey, Troy, go ahead. Troy, you have access if you want to turn on your mic and ask a question.
There we go. It's actually Jim Anderson and myself. I'll let Jim ask a question here.
Good. Thank you for your presentation, Dr. Rojas. It's nice to see you again, too.
Yeah, Troy.
And you've seen us before. We have several questions. I'll go one by one. We acknowledge, I think, your site selection 2 and 3, we would agree totally with that. Just in commenting about the indigenous and the national parks, we don't know, for instance, with a floating plant, how they would necessarily interfere with the indigenous people or the national parks in those areas, because a floating plant offshore you probably wouldn't even see. You just have a cable coming ashore. But beyond that, my question has to do with your presumed gross kilowatts that were available at any of these sites. I question that because there's really an not infinite, but virtually infinite amount of water, warm and cold water, in those areas. There's no reason to put a limit on the amount of power that could be obtained from those sites. In addition to your cost models, again, I think I was seeing high cost HC and low cost OTEC and future OTEC, so to speak. It's very difficult. You have to recognize that OTEC is the only natural base load potential that you have. It's even more secure than hydro because hydro depends on rain. Whereas OTEC is really more secure in baseload power than any other natural form. But anyway, you can address that first question as far as the presumed gross kilowatts from any of those sites. I think that you must have made some assumptions that I'm certainly not understanding.
First of all, I want to apologize for my English, but I think that I understand the first question related with that how an OTEC light could affect those activities, and the second question was related more with the infinite potential that we could have there. In the first one, something really important is that we analyze OTEC in a real and general context. That means that we don't we have the potential, but we don't know if it's better OTEC plant in the land or the floating plant or anything related with those configurations or that types of OTEC. So for that reason, we did like a general investigation research. The second question we have actually when we went to PAMEC, Carlos Acevedo told me the same question. Why are you talking about like a specific potential if you have a lot of resources in that specific area, that specific site? This basically to have an idea, you know, but we need more information. We need more information. We need to know if we could build one plant or two plants or like I don't know 100 plants, OTEC plants. But we know that we have abundant potential for OTEC in that specific site, and also we have an ideal conditions. So that means that we have like this is OTEC simulations represent like the first idea or the first step of yeah, this is it's like the first step, but I think that we have a lot of potential. Yeah.
Yeah, dear colleagues, you have to take into account that this is the first research, not only in Costa Rica, is the pioneer work for Central America. There is no doubt in the close future, in the near future, all these hypotheses working here will be changed, not only for new methods, but also is because we have new information about a new way to get more and clear information about power capacity of the OTEC in Costa Rica. So we are not worried about that. This is when we are faced the first research on any kind of energy resource. I mean hydro, biomass, solar PV, or even in ocean like wave, tides, currents. Of course, that in the near future, all the hypotheses working that will be changed. And we believe that this is the first step to define what is the real capacity, what is the real potential that we can use in Costa Rica.
Yeah, I think
Thank you.
just gonna jump in real quick, and as we are starting to run out of time, but we can keep going over after the hour if everyone agrees. But I think there's existing studies that have done work on, you know, putting theoretical OTEC plants in the ocean within, you know, practical spaces, and then using that to determine the overall full country potential. So I think that's a little bit of a different study and maybe something down the road. But I understand you wanted to get a first grasp of where OTEC might be possible. So it makes sense to kind of take that approach. I'm gonna go to next question, and then we can come back to Troy if you have, or Jim if you have your next question after that. Okay, so in the chat, there is, next one's Cristiano. So I'll give you access to the mic and camera so you can ask your question directly. Okay, go ahead, Cristiano. You can ask directly if you'd like. Or I'll just read from maybe from the chat then.
Yes, Pablo,
So
you saw the question?
Technical breakdown of how an offshore platform integrates with transmission lines. I think this is a little bit outside the scope of your study, but if you'd like to answer any part of that, feel free.
Yeah. In this case, again, my research focus on the potential size and to identify the preliminary information about OTEC. So I think that that specific questions or that specific information, we need more. We need to do more research. We need to investigate different things related with OTEC. For now, we focus on the selection sites and the potential megawatts that we could find, we could get with an OTEC, potential OTEC plan. But I think that is a good point to keep in mind for next research.
Great, thank you very much. And next, Jim, did you have another question?
Yes, I'll just put in, I wasn't clear on your bar graph near the end where you compared the different forms of energy. You had a large high bar for, I think, what you called high cost OTEC, and then an equally high bar, but a little lower for low cost OTEC. Was I seeing that correctly? I wasn't clear on what those bars meant and why or how you arrived at their magnitudes, shall I say.
Pablo, creo que se está refiriendo a uno de los gráficos, si podrías ir.
Yeah. Let me go to the presentation. Yeah, the bars.
That one.
Near the end.
In the end, no. It's just a. It's just a image. You know, like the representative image.
This one, that one.
That one. Yeah.
It's here is something that we want to do in the future, but it's here is like a representative image. But yeah, I think that the next step could be like economic research related with OTEC, to compare OTEC in Costa Rica and OTEC what about OTEC in Mexico, for example, what about OTEC around the world, and compare the different cost of OTEC around the world if we compare with Costa Rica. But I think that is the next step that we are gonna work in.
Okay, thank you very much. Any other questions from the audience? Any final comments from our presenters?
No,
So
from my side,
OTEA,
just to thank you, Ben, to open the opportunity to speak to the big and important colleagues from around the world. For us, is a very nice opportunity, not only to introduce my colleague Pablo, but also to speak with different experts around the world. Thank you so much, Ben. Pablo.
Yeah, thank you so much for the opportunity. And sorry for my English, I'm still learning, but I try to do the best. If you want more information about this research or anything related with Red Mare Costa Rica, we are open to work together. I think that the main idea here is continue with this way, investigation, more opportunities, more student interest in ocean energies. So thank you so much for the opportunity, and I'm so happy to work if you or to collaborate if you need something.
Thanks so much.
okay, thank you. And with that, we'll bring this webinar to a close, but you're free to get in touch offline. And if you have anything to share with the OTEA community, please send it to us and we'll share it amongst our membership. And if you're not a member yet, please go to ocean-thermal.com and register.
Thank you.
Thank you all.
Thank
so
you.
much.
Thank you.